Okay, again, aloha and welcome to the Agroforestry Design Tool webinar. We are so excited to have you here. This is the kind of thing that our team loves doing, and we're excited to have so many people, not only from the Pacific, where we are right now, but from throughout the world. I'd like to start by thanking some people. First of all, the USDA, United States Department of Agriculture, Natural Resources Conservation Service helped sponsor this project, and they really have been doing great work in terms of multi-story agroforestry for conservation purposes and also subsistence agriculture in the Pacific. So we're very grateful to them. We've also had input from dozens of people on the tool. People have commented after webinars, during our webinars, and also during the development stage. So this is not just us. We're here now, but there's many people who have been involved, and we're very thankful for that. One of our teachers, Kalani Souza, always says at the beginning of a meeting, if it doesn't begin right, how will it end right? So today I'm very pleased that we have Patty Coleman, who is in Saipan and one of the movers and shakers in the Pacific Islands to open up the workshop and set our intention. So I turn it over to Patty.
Thank you, Craig. Let us take a moment to remember those who have come before, those who are present today, and those who will come after us. Let us remember that we are blessed to partake of the knowledge, wisdom, and innovation that we will freely share with each other today. May the knowledge we gain bring regeneration to our islands, our nations, and our hearts and minds.
Thank you so much. So we are very grateful for your time that you've taken to be with us. We're going to endeavor to be as efficient as possible in presenting the tool to you. And I just want to let you know that there's over 50 countries represented in today's webinar registration. So this is a worldwide effort that people are working on at many different levels. And so again, it's very exciting. I also would like to remind you that the human beings are probably the best tool, so to speak, for designing, implementing, and managing agroforests. And we have been doing this for many, many generations. In the Pacific, we have the great privilege of having indigenous peoples who carry on with their biodiverse, productive, and resource conserving agroforests that have been in place for hundreds, if not thousands of years. So I personally have benefited from observing, being welcomed into farms, and being able to learn from farmers such as these pictured here. We have the ability to predict how plants will grow together in complex systems and how the weather and how the environment will influence growth over time. And that knowledge carried on through generations is extremely valuable. So let's look at this tool that we're about to present to you, which is a computer-based program as an aid to assist us in various ways. If you already have this deep indigenous knowledge in agroforestry, the tool might be a way for you to share what you know and communicate and teach others. And for those of us who grew up in a conventional agricultural mindset, monoculture mindset, if you will, the tool is a way to assist us in learning how to grow things in complex systems that change over time in a dynamic way, and to change how we think about agriculture. So in brief, today we're going to demonstrate the tool, which is, as I mentioned, it's a free tool. It's live now, and thanks to the Natural Resources Conservation Service, it will be free and live through 2023 at least. And so we're going to demonstrate first selecting a planting pattern, how plants are growing together in a multi-story system. We will present assistance in selecting plants to fit within that pattern. And we will also show you how the tool helps you manage the plants through pruning, manage the layering of the canopies, and also visualizing the agroforest, not just at one point in time, but the progression over a number of years. Our team, in the background here, we have Neil Logan, who's co-developer of the tool, and just an absolute agroforestry genius and enthusiast, and he's dedicated his life to agroforestry, along with Sophia, who is also here. She will be facilitating a question and answer session. And we also have Nikki, who's been working in agroforestry for a number of years, and she's directing the webinar technology behind things, and also helping us organize everything we do. I will begin by speaking about the conceptual background of the tool, how we got to where the tool is now, followed by Neil, who will demonstrate how the tool works in a live demo, and we will follow that with question and answer. So as we're speaking, feel free to enter your questions into the Q&A box, and we will handle those after the presentations. And just a few notes, the tool is currently available at agroforestryx.com. You can go there, create an account, and set up projects. And as I just mentioned, please ask your questions in not the chat box, but the Q&A box. There's also a chat box for you to use, but please put your questions in the Q&A box. And please know recordings of the webinar. We will post a webinar recording to the web for your reference some in the near future. Okay, so how did we get to where the tool is now? One of the mantras of agroforestry around the world is there are no recipes for agroforestry. Every project is different, every site is different, the goals are different, and the mix of species that are desired are different. So there's no clear-cut recipes. In the literature, agroforestry is presented in many places as practices. Different practices are categorized as agroforestry practices. So here's a few of them shown here, such as alley cropping, contour hedgerows, forest farming. We felt that because practices actually can be very fluid in how they're implemented. For example, an alley cropping project can also be a multi-story agroforestry project, or contour hedgerows can mean many different things. And so practices themselves can be fluid and vary quite a bit. So we wanted to get away from this idea of design based on practices and shift over to a more general framework for designing agroforests. This example here is one that we will use throughout the webinar today. This is a typical, or maybe not typical, but a commonly found type of agroforest in Samoa. It exists today and it's been around for a long, long time. And what you see here are patterns of structural patterns and also species patterns in terms of occupying different layers of the agroforest. And so this is a rich source of information to draw from. We might say this is a successful agroforest because it's been around for so many decades, perhaps millennia, in this way. So what you see here is an example of an agroforest that we drew knowledge from through the literature and through our own experience. These types of systems are documented by people such as Randy Thaman in Fiji, Art Whistler in Hawaii, Margie Fallenrue in Yap. And so there's a lot of documentation in terms of species composition, spacing, and the way these systems change over time. That is the foundation, one of the foundations of how this tool was developed. And what you see here is multiple layers. So at the top, you have a canopy of what we call emergent species. Those are the trees and palms that stick out above the main forest, main agroforest. Then we have 3 other layers, high, medium, and low, of other species. Additionally, this is an example of a forest that is regenerative in its outcomes. And we've been talking about sustainable agriculture for a long time, but sustainability is not enough, and many people are realizing that at this point. Sustainability means that we are maintaining conditions as they are, whereas we have so much degraded land, degraded ecosystems, that we need to improve systems, our agricultural systems, over time, which we call regeneration. That's improvement over time, consistently. Nikki and I and Diane Rigoni, a colleague of ours, wrote a paper on regenerative agroforestry. And so what we did in that paper is very much reflected in how the tool is designed. The outcomes of regenerative agriculture or agroforestry are those that you see on the screen here. And these are drawn from the regenerative agriculture literature around the world. This is kind of a summary of the outcomes that most people are looking for in regeneration. And they're pretty clear-cut and maybe obvious. So the first one is continually build soils, soil health and fertility. The second one is increase water infiltration. So we want, when it does rain and water is available, we want the water to soak in and be held there. And any water that's excess would flow off cleanly without erosion. The third goal, the third outcome is biodiversity. That is increasing overall biodiversity of the system. The fourth is ecosystem health, which is essentially means the ability for the agroecosystem or the farming system to withstand stresses and also the ability to renew itself continually. And finally, it's carbon sequestration. So our goal is really to achieve these outcomes by designing our agroforest in such a way that we know these outcomes are going to be met. And that was the focus of the paper, which is open access. You can read it yourself if you're interested. But the principles, the general principles of regenerative agroforestry that we identified are those that are shown in the simple diagram. That if you achieve these things to a certain standard, to a certain level, you will also get the outcomes of regenerative agriculture that you're looking for. So the first of these is integration, the integration of perennials, woody perennials. The second is your density of plants, of woody perennials per unit area. We want a minimum density of those types of species. The third is multiple species, so having many different species, many different plant families, varieties, all of that represented in the system. And finally, the structural diversity, which is the multiple layers of canopies. So this forms the basis for how the tool works. And in order to help visualize this, we use a color-coded system for the different canopy layers. And in this diagram, you can see from the top down, the blue is the emergent species, those widely spaced species that stick out of the forest. Then we have the high layer, which is in green. Those are the species that can take some shade but need a lot of light and are taller, naturally taller than other species in their native environment. The yellow is medium, those take more shade, and then low is the perennials that are the most shade tolerant, and those are in red. The ground level species are very important. However, in our design work, we allow the user just to pick the ground layer species themselves, and that's not part of our design. So going back to that Samoan example that I showed you, that photograph, here we overlay the canopies of the different layers in that system. So at the top we have coconut and another timber tree that Samoans love to use, which is called pomuli. And below that we have breadfruit, which is the high layer. That's it requires quite a bit of sunlight, but it also tolerates the shade of the emergent species. And then there's banana and cacao or chocolate under the breadfruit. And finally, we have noni and kava as understory species. One thing I neglected to mention earlier is that all of these, I shouldn't say all of them, but many of these species, including the breadfruit, are pruned in this system. Pruning is the way this layering or stratification is maintained, and that's very important. That's why we include that in the tool. So now we're getting somewhere. We have the beginnings of a design in terms of categorizing our species, in terms of the layers they occupy. And we have a sense for the diversity of species in a functioning, regenerative, indigenous agroforest. And there's another piece of this, which is succession of species, which I'll talk about in a moment. But we have the beginnings of our design from this layered canopy structure. In indigenous systems, however, the spacing or the organization of plants in the system tends to be somewhat random, or it looks somewhat random to the outsider. To the producer, it's not random, but it looks unsystematic in its design, and it's very hard to teach people how to do this in a kind of randomized way, such as depicted here. This is my drawing on the left here of that Samoan agroforest. So part of what we're doing in the tool is we're taking a leap into an organized row-based planting, which is much easier to conceptualize, much easier to manage, especially if you have machines, and it's much easier to teach. So this is a strategy used by many people around the world now, this row-based multi-story agroforestry design, and we're inspired by Ernst Goetsch and Henrique Souza and many others who work with Ernst in Brazil. So this is the first concept of the design tool. This is a screenshot from the tool itself. So the tool is based upon planting patterns. And these are row-based, organized, multi-story systems where each layer of the canopy is color-coded. And we have included a number of patterns. We plan to include more, but right now we have, I believe, 8 patterns. And these are drawn from either the, uh, the, the experience we have in native systems, the literature, and so forth, into a kind of a generic pattern. And each one of these differs, each differs in different ways. And while you're using the tool, you can click on the info button and read about what we think are the advantages and disadvantages of each of these. Once you select a pattern in the tool, then you still have work to do because you're going to use that pattern in different ways and fit it to your site. So the tool is an assistant in designing your own system that is suitable and appropriate for your specific goals. So for example, if you pick pattern 1A, which is shown here, you will orient the rows in the way that you want, according to the slope, either a cross slope or up and down slope, depending on your goals and orientation to the sun. And similarly, if you have existing trees on the land, you will have to adapt this pattern to your existing trees if you're going to retain those in the system. So you will have to adapt the pattern to your location. Here's another 2 examples of adapting the pattern. If you're going to plant a windbreak, for example, a multi-story windbreak, you may choose pattern 1A and use 3 rows of pattern 1A as outlined in the orange box. Or if you're planting an area that's smaller than one of our patterns, the patterns are roughly 30 by 30 meters or 100 by 100 feet. So that's large for some food forest home gardens, and you will pick a section of the pattern that will work for you. Similarly, you may have different zones on your farm or your project site that require different patterns and different species. So the tool is set up to allow you to pick, we call them projects. You can do a project for, let's say, a poorly drained valley, and that will determine the planting pattern and the species you use. Or if you have another area that's a very dry hillside or hilltop, you have a different pattern and different species. So you'll use different patterns and different species for different zones. Now, I want to talk a little bit about succession, because what you don't see in that Samoan example is that it didn't start out as a planting of just those few species. It started out as a planting of many species, and some of them were long-term, which we see in the photo, but some of them are short-term or medium-term. That's our language for the plants that don't last longer than about 4 years. So our planting patterns, this is the long-term plants of a planting pattern. It's also pattern 1A. You can see within the rows, there's a lot of unused space. And that space needs to be either maintained, which is the way lots of people do it, but it's very frustrating because you're maintaining the space in row and between rows with no productivity and very little, productivity of, say, food, but also productivity of other things such as organic matter are limited. So we want to use that unused space in the rows. And you can see on the right-hand side, that's an example of that. This type of system is often extremely frustrating for people because they have to wait many years until they get any yield. So what we're doing is we also give, within each design, a planting pattern for the medium-term species. Those are the ones that grow up quickly, they produce early, and then they disappear after 1 to 4 years. So we have a whole range of medium-term plants that we're also going to plant in the system. And we don't illustrate those together in the tool because it gets very complicated and messy. But in this drawing, I've overlaid both of those plant assemblies into one to show you. Now we have our rows, which are beginning to fill up, the darker green, with medium-term and long-term species. And we have the paths between the rows. So now we're starting to form densely planted agroforests within the row. The next part of the tool, after you've selected your planting pattern, is your species selection. And Neil's going to go through how this works. Essentially, what happens is you're presented with a list that is broken down in terms of the time frame in which it's in your agroforest, long-term and medium-term. That's in time, as well as in space. So those lists are broken down further into which canopy layers each of those lists of species occupies. So these are also filtered by the environmental conditions of your site. So you're presented with a list of, like a menu of species that you can select from to use in your planting pattern. And finally, getting back to the concept of maintaining that layering through pruning, which is very important. After you've selected your species, you have the leeway to select how your species will be pruned, if at all. Okay, so at this point, I'd like to turn it over to Neil, who's going to do a live demonstration of the tool so you can see how this actually works. And as I said before, I've been working with Neil for many, many years. He's probably one of the most dedicated people in agroforestry I've ever met. He's devoted his life, along with Sophia, to agroforestry. So take it away, Neil.
Hello, everyone. My name is Neil Logan. I'll be guiding us through the use of the tool today. We're going to start out first by signing up and making an account. Go here to the sign up button and click. And then you can go in and type in your username, your password twice, and then your email twice. And then be sure to accept the terms of service and click the submit button. Now, if all goes well, you will have created an account. You can now go to the login page and enter in your username and password and click submit. This takes you to the projects page. Now, when you have a new account, there won't be any projects in here yet, so you'll have to create a new one. If you have previously had an account, then you would have projects in here with some of these basic details. Also note that at any point you can return to the home page or to our support page if necessary. So now I'm going to go ahead and create a new project. I'm going to name this project. And then I'm going to select a location. And in this case, I'm going to try to recreate the American Samoa example that Craig showed us earlier. Now, this tool is useful for the target project area, which is the US affiliated Pacific Islands, and has been populated with pantropical species. So if you don't find your location on this list, you can go ahead and select any. And that will give you a generalized context for species selection. Go ahead and put in your rainfall. I'm going to do a little bit on the drier side. You can do this in inches or in millimeters. Then you want to select your soil drainage. I'm going to go for medium. Your topography, I'm going to select flat. Now, if you don't know, or if you just want to create generalized projects, you can select the any option. Elevation is in feet or in meters. And the minimum size for a project is about 1/4 acre. You can do this in acres, square feet, square meters, or hectares. I'm going to stick with acres, and I'll make this a 2-acre project. Now at this point, if you would like help with your design so that you can comply with particular standards, either the nrcs standards or the regenerative standards, this is where you would select for that. If you're unsure, go ahead and click on the question mark, and a pop-up window will display information and links where you can get more details about the particular standard you're interested in. If you don't need help, you can just select no restrictions and then proceed. This takes you to the pattern selection page. Notice up in the top left corner there is a box with your project details. Now as you scroll down, there's a graphic that explains the path widths. And here you have 2 options currently, 15 feet or 20 feet. I'm going to stick with the 20-foot or the 15-foot option, excuse me. And now we have different patterns presented for selection based on that 15-foot path width. Now when you're trying to determine which pattern to use, you can go ahead and click on the info button for the one you're curious about, and a pop-up window will display more details, including these 2 charts broken down for the long-term and the medium-term species, which tells you by strata the spacing within row and the spacing between rows and the total number of individuals for each stratum, as well as a little description when you're satisfied that you've picked the right one. Go ahead, select it, and go to the Proceed button. This takes us to the species selection page. Now when we get to the species tables, you notice at the top there is a quick search function with a drop-down menu. So if there's a particular species you're looking for, you can go ahead and click on that and either type in the name or scroll through and look for it. The species selection has been broken up into 2 tables, long term and medium term. Each stratum contains information about the maximum range of growth for each species found within that category. Again, you also have the total number count available for that particular time period and stratum. So here you're prompted to select some, and we're going to go through this one term stratum at a time. So I expand the organisms by clicking this button, and now the whole list appears. And I can scroll through this, and I have a little picture, a general concept of what the organism would look like, its common name, Latin binomial, the habit, time to removal, propagation methods, and uses. Just some basic information to help you select your species. So I'm going to look for things that I recognize could work in the Samoan context. I won't pick too many. Now, here's something interesting you should know. There are at least two ways that I'm aware of to select species that we don't currently have in the data set. So if you want a species that you know will grow in your project area, but you don't see it on our list, then one way to deal with this is to go and find an analog species in the list. Find an organism which more or less grows in the same height and rate as the organism you want, and select that analogous species. Later on, when you have the list in the report, you can just cross out the name we've given and write in or type in your own name. That's one way. Now, another way is through the use of the Your Choice options. And here we've given you three. One with a fast growth rate, one with medium, and another with slow growth rate. These are generalized so that you can select whichever one will be closest to the organism that you choose, but is not evident here. So the data set is populated with information that pretty much works for the tropics and subtropical regions. Now, to go outside of that region, those regions will be difficult because we haven't really expanded into there yet, but we're working on it. But for now, I have been able to create projects using species in our data set for areas with as low a rainfall as 30 inches. And I have created projects using our data set for 20 inches. However, one of the stratum terms required that I selected one of these Your Choice because there were no other options. So I would say functionally this can go to 30 inches rainfall annually, and you can stretch it at least down to 20 inches, which I would say generally covers reasonably all the areas where agroforestry is practical within the project region. So we're going to move on to the the long-term medium. Expand into here. Let's see. I'm going to select banana and cacao. How about noni? So you can see it's quite an extensive data set, though still a drop in the bucket for the entire tropics. We could have thousands of species in here. So here I'm in now to the high stratum, and I'm going to add a few things to this just to give a little bit of diversity. And to make sure I can feed the system. Okay, and now for the emergent. So we can select up to 4 of these if we wish. However, to keep this simple, I am going to just do this and boom lily. I think that's more or less what Craig had in the image. So now we're to the medium-term species. These are the species that live up to 4 years. And again, you have the height range for each one and the total number of individuals available. And I'm going to go ahead and pick some of these root crops. That looks pretty good. And I'm going to add giant taro and kava. Taro. All right. And let's see, finally, the medium term emergent. And we'll do some how and papaya. I think that'll do it. So for the short-term crops, we are not including the short-term crops in this initial part of the design process, mostly because to visualize them makes for very complicated visualizations. So instead, what we're going to do is at the very end in the summary report, we will give you a couple of tables with species recommendations, with information about planting and harvest and that sort of thing. So I'm going to proceed to the next step, and this is the pruning variables. Now, here you will notice we have a diagram that shows the height at which you're going to prune. So this triggers your pruning when you get to this height, and you're going to prune it down to this height. So you're basically letting your organism grow between this range. And the same is true here for canopy diameter, right? Okay, and so when you get to this table, all of these should be white. Now if I modify them and say I want to let my chili pepper grow to 6 feet before I prune it, that's fine. You'll see that is indicated by the orange color. And if I go down in here and I try to make for, let's see, an erroneous choice, it's going to give me a big red box and say, hey, that's not going to work. So I can go ahead and fix that, right? And over here, we are given the numbers of individuals per each quarter acre plot, 100 by 100 feet. So these are all interlinked. And so if I update one, it will reflect in the others. see that? And so now let's see, I'm going to make this go up to here. And I'm going to leave those pretty high. This I'm only going to let it go to here, like that. Okay. I'll leave those the way they are. And let's see. I want these two to grow larger, and then I'm going to prune them harder. Okay, so I'm going to leave that like that for the height, and for the diameter, let's see, I'll do the same. Okay. Oh, doesn't like that. All right, I'll pause it at that, and I'll bring this down to here. How about that? And these we're going to leave, and this we're going to leave, although I might just bring this down to here. All right, how about that? And we got 2 and 2. We'll leave that. We're going to have 2 of these, and how about that? All right. Now, for the medium term, here, can't do anything. All we can do is change the numbers of individuals. This is due to the nature of these organisms. Similar things going on here. I'm going to let that get a little bit bigger. And, fine. Okay. This all looks good. Increase the diameter of this. All right. All good. So now I'm going to go ahead and proceed. This takes me to the visualization page. Now here, you'll notice we have these tabs at the top. The initial planting view, the 3-year view, 3-year side view, and 10-year view. And you can toggle between these views as needed. We start out in the initial planting view, and so here you can see the layout of the different organisms that you chose and where they would fall on the pattern. Color coded, of course, by their stratification. And we have it broken up into long-term and medium-term. So in reality, these would be overlaid upon one another. But to make it easier for visualization, we have separated them. And this is why we did not include the short-term, because you can imagine with the short-term organisms here, this would just be a mass of dots. So then we'll move over to the 3-year, and you can see we have percent cover for both the long-term and the medium-term. So this is the total area covered by the canopies, the combined canopies for each time period. And so if you were to actually put these two together, you have like 94%. And if you consider that you would have, let's say, grass or cereal crops or biomass crops in the paths, you can imagine you would have much more than 100% coverage. And again, these are all live, so you can go through here and see who's who. And then side view. And you can tell the difference between the long term and the medium term because the long term have solid lines and the medium term have dotted lines. And the 10-year view. And here we have 86% coverage. Okay, so if this all looks good, then we're going to go ahead and go to the animations. Now, at any point, you can pause this, you can refresh it, or you can grab the time slider and hold it or move it to any point in time that you wish. And this is a very useful thing to be able to do, especially when looking for canopy conflicts. So I did this on purpose to give you an example. You'll notice here these are all greens, so this is all high stratum. And at a certain point, they are actually beginning to touch one another. And this is where conflicts can begin. So it's not a problem for organisms of different strata and time periods to be close or overlapping with one another. There's no conflict there. The conflicts occur between organisms of the same time period and stratum. And we'll go back in a second and look at how we can resolve this situation by changing the pruning variables. So you can let this run all the way through to 15 years. Now, as we found those conflicts, we want to address them. So I'm going to go back to pruning. And I'm going to go back to the long-term high stratum here in green, and I'm going to see if I can change some of these. So I'm thinking I'm going to reduce this and reduce this, and let's see if that resolves the situation. This basically means we'll be pruning these organisms sooner. Before they begin to overlap. So we'll look again at around the 6-year point. And so far so good. Looks pretty tight. Right? Now, consequences of this also will have relevance in the canopy coverage. So let's see how that impacted. Looks to be about the same as before, and let's look here. So a little less coverage now because we're pruning them earlier. So ideally, you can tighten this up by manipulating those pruning variables several times until you get it to just the right place. And now if everything looks good, we can proceed to the summary page. Now here, you still have your project details at the top. We've gone ahead and organized the species list according to their term and stratification. And we've added the estimated number, total number of individuals of each species in the project here. So this is great to have if you need a shopping list to go to a nursery and get your germplasm. You can show up and say, I need 52 of these and 87 of these and that sort of thing. And lucky you if you have such a nursery nearby. And your pruning variables are all here as well. So this is kind of like your blueprint, your management blueprint for managing your area for this project. And then we go into the medium term. And here we have the visualizations, again broken up, initial and the 3-year and the 10-year. And these are still live, so you still have a chance to look this over and make sure this works for you. And here's the 3-year, again with your medium cover and your long-term cover here. Three-year side view. And your 10-year visualization. There's the pumuli. Okay. And there's the coconuts. And finally, here are your ground cover species. Some basic production notes. And recommended short-term crops with your harvest cycle included. And now, if you're satisfied with this, you can go ahead and print a report. You're going to want to save this somewhere on your computer. It will download, and then you can go ahead and open it up. And here you have a 21-page report that has basically everything that we saw in the summary and a little bit more.
Hi everyone. I think actually, Craig, you're gonna start off the question and answer. Isn't that correct?
Okay, actually, yes. We've had a number of questions about how these systems actually work in real life, and can we show examples based on the tool? So I am going to actually go back and share some pictures. One moment here. Whoops. You just give me a second. I will share my screen again. So the tool has only actually been live for a couple of months, so we don't have any examples per se directly taken from the tool. However, Neil and Sophia and I have been working on various projects around the Pacific, and this is an example, and I believe Andrea Dean's on the call on this webinar as well, from Hokonui, Maui, which employs the principles of the tool, and so it's a very good example of how this successional agroforestry type of system works. And so this is old sugarcane land that was then in pineapple and then in pasture. So it's a pretty beat up site, like many agricultural sites in the Pacific and around the world, in terms of soil quality, soil structure, water holding capacity, etc. So the very first thing we do, and this is kind of outside the realm of the tool, is we prepare the site so that conditions for growth are suitable for all the plants that we want to be growing. In this case, there's native species, there's fruit trees, there's food plants, all mixed together. And so this is an example of what this type of system will look like. You can see after preparing the site, adding compost and mulching, that we get very rapid growth. This is just in 2 months. You can see the kalo, the taro coming up. You see bananas. You see some fruit trees in between the taro rows, and lots of things emerging simultaneously. So we have our short-term, medium-term, and long-term all growing together here. And after 3 months, looks like this. And finally, at 6 months, we have, let's say, closed canopy of crops and different food plants. These are the medium-term species you see here. You see papayas, taro, banana, sugarcane, all coming up. Underneath this, you see you don't see the fruit trees and the long-term species that will eventually succeed and take over. And one of the keys here is that within a very short period, with taro, it's 9 to 12 months, this prepared site produces a lot of food. And so a lot of food came out of this, which was either given away or sold. But the idea is that rather than waiting for our long-term species to begin yielding many years from now, we have yields very quickly. And this is after about a year and a half. You can see things have advanced quite a bit. The short-term crops are gone, and now we have long and some medium-term species growing in the rows. And this is the Heva Heva Ohana who carried out that project. This is another example. This is an example for those of you who already have an orchard or a planting of some sort that you want to turn into a multi-story agroforest. This is a project at the National Tropical Botanical Garden. And so the thing about an orchard such as this is that if you were to plant underneath these existing trees, these are breadnut trees, you would not get very good performance, because essentially the space underground is taken up by the roots of these trees, and above ground there's a lot of shade. This is not the conditions in which the vegetables and medium-term crops and other long-term crops would grow well. So we did what we call an intervention, and the intervention is we prune the trees heavily. So the pruning sets off a whole new wave of ecological activities in the soil and with the plants that are there. And by that I mean, now this area is in a condition in which things will actually rapidly grow if we introduce new plants, our new planting. And all of the organic matter, by the way, all of the prunings were chipped and used fed back into the system as mulch. So we prepared our rows. These are rows right along the existing rows of breadnut trees. We did that. We did that preparation by hand because of the existing trees. We didn't want to damage their root systems too much, and we prepared very nice planting beds by digging deep through the subsoil and adding compost, nutrients, and mulch. So this is what the rows look like once they're prepared. And now's the time to introduce our new planting, our new wave of agroforestry growth. So we plant very densely along those rows. That bed is, you could imagine that bed is one solid, well-prepared vegetable bed. And we didn't only plant vegetables, we planted our medium-term and long-term crops together with those. So after a couple of months, it looks like a vegetable bed. You can see the beans and the eggplant and the kale and Swiss chard and many things coming up. Again, what's hard to see here is that our long-term and medium-term species are all growing within this vigorously renewing multi-story planting. And so once the vegetables are gone, a few months later, you can see now we're dominated by our medium-term species. This would be the taro, cassava, we have banana, tea leaf, and several other medium-term crops. So those have now taken the space from the original vegetable-dominated area. And again, within there we have our long-term species, which included things like cacao, coffee, vanilla, black pepper, etc. And you can see the vigorous regrowth of the trees that we had pruned. So once you prune like that, everybody starts growing vigorously, and that's the idea. We want to ignite the regenerative engine that nature, in a way that's harmonious with natural processes. Okay, those are the two examples I have to show you. There are others, but for time, I won't show additional slides.